Hello everyone, this is Hakim. Welcome to part 2 of Mobius strip design in Grasshopper. From part 1 we have created our own Mobius strip. It's here, and today we are gonna create the Voronoi surface for it. And the major technique we're gonna use today is to design the rectangular Voronoi surface and flow it onto the target Mobius. And we are going to use transform flow along surface. Let's do it again. Base surface, target surface, and that's here. Then we offset with a kind of distance. Remember, the solid is yes here, and basically that's it. So the challenge here is to create the Voronoi, and let's see how we're gonna do it in Grasshopper. In Grasshopper, the first step is to create a set of grids. Let's say here, and now let's give it a number first. We'll give it 20 for the X, and say 5 for the Y, and yeah, that's it. And we're gonna use the centroids of each of the cells, and with the centroids here we give it a random movement, and we use Voronoi. Let's see, we're gonna move it by Y direction, first we need to create a set of a series. Since we have 20 by 5, that is the 100 cells, and we need a series of 100 items starting from 0, each with a count of 100, and we give a maximum step as 0.5 divided by 100, and use it as a step. I'm going to show you here. So each step is 0.005, and we have 100 items here. So we have create a list or a series from 0 to 0.5, and we give it we jitter it, so we give it a randomize the list. And it give it to the distance in Y direction. Let's check the data structure. Yes, that's the 100. Alright, and let's see here. Yeah, we need to flatten it here. Well, today we are not gonna talk much about the data structure, but I hope that you guys learn it through practice. The data structure should match before you move on to the next step. Basically, it's here. Say you have 100 individual items, and here you also need 100 individual items, and that is why I need to flatten it, because otherwise it's in a tree it's like it has 20 branches of 5 items in each branch. And we do the same thing, and sorry, this is in Y direction, and we're gonna do it in X direction, and we give another, we jitter it again, move, and that's it. Yeah. Let's see. Okay. So we have randomly moved the central edge a little bit, and we can now use the Voronoi. And for the Voronoi, let's check. The first is the input is points, radius, what doesn't matter, and boundary. Of course, it needs the points and the boundary, and for the boundary we can create our boundary ourselves. We use box to point. So the first point is the original point. We can construct the points, and this is as the point A, and we move it a little bit, say move in X direction. X direction is here, and we move it again in Y direction. The Y distance is here. That's another, and input as the second point, so we have create the boundary ourselves. So now let's check the data type first. 100 individual items, yes, of course, and that's it. Since let's see what we got. We have another 100 curves. Well, a quick way to do that is use mesh tool, but well, just as I believe, mesh does not work perfectly with NURBS. So today I suggest that you guys work in NURBS if possible. Well, actually, in this case, mesh is the faster. Well, you can figure out yourself. Sorry, we don't have much time for that, but I believe the curve is a better way in our case, because you can manipulate the curves more freely. Let's say we divide the curves by 5, and we create NURBS based on the points here. Change the Boolean set to true, and that's it. Okay, that's what you got. And you can offset the curves to create enough area for it. Give it a distance, say 0.10, smaller than 0.5, so you can adjust it. Well, negative in the okay, that's working pretty well. Let's double check on that. Alright, that looks right. this is 2.5. Maybe we let's do it. Now it looks good. Yeah, again we use the boundaries. Deconstruct, wrap tool, and we use curve join. See, each item is on a separate tree branch, and we need to flatten that. And again we use surface tool, surface boundary, press on shift, it's not quite right, I guess. But yeah, the thing is, as you see, if we flow this Voronoi rectangle onto a surface, you can see clearly the four edges, the boundaries, the opposite edges perfectly match with each other, and so there's something more we need to do now. Some kind of tricky part here. I hope you remember this as some kind of trick you will use a lot in the future. Points. Move in the x direction. X is 20. Okay. Move y direction. Y is 5. Move another y direction, and that's here. Now we're gonna use the merge tool. Merge the 4 sets of points, and let's check the data status. We should have, yes, the 400 individual data items, and so our boundary should also double, that is times 2. The x direction times 2, give it to and also input the y direction into times 2. Also change the set of points. That's what we get. Now we create the new boundary. We also start from the original point. So the first point, the first corner of the new boundary is the move by x direction. Oh, we do not need this. Half x, half y. my mistake. Now the whole x and y, that is on a 20 by 5. And a new box. So in this way, the opposite edges should perfectly match with each other. Grab with grab and create this surface boundary again. Alright, so you can bake it exactly as here, and well, honestly, that's basically what it is. Well, you can also yeah, since in Grasshopper we can see how this is done totally in Grasshopper. We use copy trim and input the base surface and the target surface. And that's it. Bake. We can bake the target surface, we can bake the base surface as well as the boundary box. And just do it by hand, and that's not much difference. Well, you can think about it for a little bit and figure out why it is like that, but see here, yeah, it's working pretty nice. See, and then we offset surface. Remember here, solid is yes. Give a distance 0.2, about right, and let's do it. Let's set it in render view. Well, we have our Mobius strip in the volume, and congratulations everybody. So now you can click on that, export to STL, and you can 3D print it. Well, thanks for watching again. Hope you enjoy this tutorial. Thank you.